All right, so we're going to start simplifying radicals. You do this as early. Guys, quiet. You're talking too much while I'm talking, okay? So, stick with me. All right, so you do this as early as Math 1 in the basic form. And then we'll see to what extent you've been exposed to this. I'm not exactly sure. I know that this is a section that I kind of added in because a couple years ago they were having trouble with it. So you may already know how to do this pretty well, but we'll just see how it goes. So your perfect squares are numbers that you can take. You guys, if you have your computer up, please shut that. We don't need those right now. The perfect squares are numbers you can take the square root of and get a whole number, right? So 1, 4, 9, 16, 25, 36, all the way up. 144, they go past that, but you should have them memorized up to 144 because you should know your multiplication tables up to that. So what we're doing whenever we simplify radicals is we are breaking this down to make the numbers smaller. You could type it into the calculator. It will give you a decimal approximation. That decimal approximation is not exact. So it is sometimes preferred to use what's in the square root or to simplify. So what we're going to do with these is we need to break this into two different numbers that we can multiply together. We've got 125, so we could multiply, I'm sure there's more than one thing. We could do 5 and whatever you get whenever you do this here. But we want to break this into something that is a perfect square and then something else that is not, right? So which one of these perfect squares is going to go into 125? 25. So we could make this 25 times 5, right? And so when you see the square root of 25 times 5, this can be thought of underneath one square root, or it can be thought of like this, square root of 25 times the square root of 5. It could be broken into two separate square roots. That is true for multiplication or division. Okay, it is not true if you got square root of 9 plus 16. You cannot make that square root of 9 plus square root of 16. That is, so if plus or minus sign, you can't do it. But as long as it's multiplication, you can break it apart. You don't have to write that step. What is the square root of 25? It's 5. We've taken the square root, so it is no longer underneath the root. And then we have to just leave the square root of 5 underneath because we cannot take that square root. So this would be our simplified form of this. Okay, questions? All right. 192. Now, what I find a lot of students have trouble with on these, and you will be allowed to use a calculator on these, because some of them, like 192, you're not going to know automatically what goes into those numbers. But, like, what a lot of students do is 192, they'll see maybe a 4 goes into it. It does go into it. It goes 48 times. So they will break this down into, you don't necessarily need to write this down. You can if you want, but 4 times 48. Right? Square root of 4 is 2. You got square root of 48. Here's the problem with that. 48, will it break down? Yeah, you could break it down. So to avoid running into that problem, if you start with the bigger numbers, right? So 4 here, 192, you know something like 121 is not going to go into it. 100 is not going to go into it. I don't think 81 will. 64 might. Yes, 64 goes into this. So if you use 64 right off the bat, 64 times 3, what is the square root of 64? It is 8, and then the 3 just has to stay underneath the square root. Now, if I had done this the other way, I could eventually get to the answer, but watch what has to happen. I might break this down into 4 times 12, which gives me 2 times 2 times the square root of 12. That's 4 square root of 12. Then 12 breaks down into 4 times 3. So that's 4 times 2 times the square root of 3. That's 8 square root of 3, right? When you take the square root of the 4 right here, you get the 2. Yeah, and it's multiplied by whatever is out front there. So you can see that's a lot of work, whereas if you just pick 64 from the beginning, it's much less work. So you want to try to use the biggest numbers that go into the number instead of the small ones. It can work. I'll also give you a warning here. Do not leave 8 or 12 underneath a square root. If you have square root of 8 or square root of 12, it will break down further. I'm just giving you this warning here because for many years of grading things, I will tell you that lots of kids leave 8 and 12 underneath a square root. There's other numbers you can't leave under a square root. This is just a very common mistake. 8 seems really small. It seems like you should be done, but 8 breaks down into 4 times 2. So you'd have to break it down further. If you have a square root of 8 or a square root of 12, you're not done. So watch out for that. All right, for number 3, I've got square root of 80. So what numbers could I multiply to get 80? 16 and 5. Now my freshmen that have never seen this before, they'll automatically want to do 8 and 10. Why is that no good? Neither one of those are roots. You can't do anything with it, right? So that doesn't get you anywhere. Even though it's true, it doesn't get you anywhere. But 16 and 5 does, because square root of 16 is 4. The 5 stays on the inside. Okay. Questions? All right. Okay. Let's talk about what to do if we have variables involved. Okay. So when I teach this in Math 1, I teach them that the square root is like a prison, and there are only 2 ways to get out of prison. You can either be perfect or you can escape. So I go all the way back to doing this. I'm going to do it once just for your sake to help you remember. And then we'll look at how we can sort of shortcut that. So I write this out like this. I write 6 x's and we got 7 y's, right? So 25, it's perfect, so it can escape the prison, right? Or it gets out because it's perfect. It was actually, I guess it's been found innocent here. 25 square root of it is 5. It's not the same number because prison changes you. You will never be the same again. Then, whenever you have your variables, your x's and your y's, these are like little prisoners. The x's and the y's are like different prison gangs. Okay? So, x's are not going to help y's escape from prison because they're in different prison gangs and they do not like each other. Okay? So, in order to escape, you must have a partner. But if you try to escape, what is going to happen? One of you is not going to make it. One of you is going to be shot. Sorry. Not even thrown back in prison. You're gone completely. Yeah, so pick a partner that is slower than you whenever you're escaping. So you got 6 that try to escape, but only 3 actually make it out. So it'll be x to the third, yes. Over here, you got these partners. They try to escape. So you got 1, 2, 3 Y's that get out. But this poor fella didn't have a partner, and he just knows that no way he's getting out. So he's just got to hang out in prison because he can't find anybody to help him escape. So what you end up with is 5x to the third. You got 3 prisoners here that get out. You got 3 more. The other 3 x's and 3 y's, they're gone completely.
Divide by 2, it's not,
Yeah. Yeah. So basically, half of the X's that try to escape are going to make it. If there's an odd number, you got to just leave that extra in there. So whenever we're breaking this down, like in number 5, we've got 75. So we're going to break coefficient numbers down just like we're doing with the others. So that would be 25 times 3. And then we want our x's and our y's to have even exponents. In this case, both of them do. So I'm just going to make it x to the 4th and y to the 4th. So whenever I take the square root of 25, I get 5. It goes on the outside of the square root. The 3, it cannot escape. It stays inside of the square root. X to the 4th is going to try to escape. How many of the x's are going to actually make it out? Just 2. Y to the 4th is going to try to escape. How many actually make it out? 2. None of them are left because they all tried to escape. They either made it or didn't, right? But they're not in prison anymore. This would be our answer. We need to multiply that 2 and that 5 together. So we would get 10 x squared y squared times the square root of 3. So whatever is out front, like that 2, you're just going to leave it out there. You don't do anything special with it except for multiply it back with whatever escaped there at the end. So we've got 2y to the 3rd. It's just going to kind of hang out here. 72, how can we break that down?
36 and 2.
36 and 2. I've got x to the 7th. So what I'm going to do with it, because it's an odd number, I'm going to make it x to the 6 times x. And then I've got my y squared. It's even, so I'll leave it like it is. So I got 7. Because it's odd, I just go down to the next even number and write my extra straggler x alone. And so I'm going to have 2y cubed. Square root of 36 is 6. It goes on the outside. The 2 stays underneath the root. I got x to the 6. That's going to be x to the 3rd whenever we take the square root of it. This x right here had no partner. He's stuck on the inside. And then I've got y squared. It's just going to be y to the 1st power whenever it tries to escape. And so 2 times 6 is going to give us 12. I can put that y to the 3rd with the y to the 1st. So I'm going to write it 2x to the 3rd, y to the 4th, and then the square root of 2x. It does not, make sure your exponents are the same. So the y has to have a 4 with it. It does not matter which one you write first, but it is more standard for them to be in alphabetical order. That's how usually answer choices will be given. You'll be doing delta math on this. I think it'll count it either way, but I'm not 100% sure about that. Because it can be, sometimes it's a little weird on how it takes things. But mathematically speaking, it does not matter if those are switched. Okay, questions so far? I do this stuff in Math 1. So that's the level that we're at here. Have you guys seen it before?
Yeah.
Okay, all right, good. All right, rationalizing the denominator. So the powers that be in mathematics decided that we don't like square roots to be in the denominator of a fraction. Okay. I somewhat disagree that it really matters, but it doesn't matter because the powers that be of mathematics have said that they don't like square roots in the denominator. So when you look at answer choices on standardized tests, or when you look at the answer keys in textbooks, they usually rationalize the denominator. So we have to know how to do it whether we like it or not. To rationalize the denominator, a square root that is not a perfect square is an irrational number. What is an irrational number? It goes on forever. Is something like 1.333333 repeating. Is that irrational? It is not. Because you can write it as a fraction. Repeating decimals are not irrational. But if you have just crazy repeating or crazy decimals that do not end, that do not repeat themselves, then those are considered irrational. E is irrational. Pi is irrational. Square root of 3 here is irrational. So they've decided that we shouldn't have one in the denominator, I guess because it can't be written as a fraction. They don't want that in the bottom of a fraction, right? So if we want to get rid of the square root in the denominator, what we can do is we can multiply by that square root on the top and the bottom of the fraction. Okay? Can anybody tell me mathematically why that's okay? Okay? Square root of 3 over square root of 3 equals 1. Right? And so if we multiply by 1, does it change the value of anything? It does not. So we can do this because what we're really doing is just multiplying by 1, and the value of what our expression is going to stay the same. But it'll change the way it looks. Yes. So in the top, you cannot multiply things together when one is on the outside of the square root and the other is on the inside. So you just have to write this 5 times the square root of 3. And what is the square root of 3 times square root of 3? It is just 3, right? A couple ways you can think about that. Square root of 3 times square root of 3 would be the square root of 9, which of course is 3. Or you could think of it as it would be square root of 3 squared. Square roots and squares undo each other, and it would be 3. Either way you think about that there. When you multiply a square root by itself, it's just going to give you that number underneath the square root with no square root at all. And so we consider this rationalized here because my denominator does not have any square roots in it anymore. Okay, questions on 7? Have you guys done that before? Okay, you've seen it? Okay, all right. 8 is a little bit different, and it is different because will 18 break down? Yes, it will. So you have the option of doing this, breaking it down before or after you do the problem. I'm going to do it both ways so you see the difference here. Okay, so we could do just like we did the last problem. We could do square root of 18 over square root of 18. And it will give us the square root of 18 over 18. Cut this in. All right. Okay? It does not because the top is underneath the square root and the bottom is not. 18, however, will break down. That is square root of 9 times 2. And then the square root of 9 is 3. So we got 3 square root of 2 over 18. Square root of 2 over 6. Yes. And then the last thing we want to do is 3 and 18. Those reduce. So this would reduce to a 1. This would reduce to a 6. So you would just have square root of 2 over 6. And that would be your answer. That is one way to do this problem. Let me show you the other way. I kind of prefer this other way. Okay? So the other way to do this is to break it down first. So square root of 9 times 2 is 1 over 3 times the square root of 2. Right. When you're trying to rationalize, you can multiply by just the square root. You don't have to do 3 times square root of 2. You can multiply by just square root of 2 over square root of 2. Because the 3 is not irrational, right? So that will give us the square root of 2 over 3 times 2, which is square root of 2 over 6. Different ways to get to the same place. Either are fine. I don't really have a preference.
So, I didn't ask, can you say
You can. It's just going to make it where you still have to reduce at the end. Yep. So especially a lot of times if you do that, you might get something you don't realize reduces, so you won't have it in simplest form. So I would say just multiply by the square root most times. But it is okay to multiply by 3 square root of 2 on top and bottom. You're just going to have a little more work ahead of you. Okay, now, that you have done before. Have you rationalized ones like this with plus signs? Maybe you need to see one to decide if you've done it before or not. First I'm going to ask myself, does square root of 14 break down? I can only break it into 7 and 2. Neither one of those are perfect squares. 14 does not break down. So what we're going to do here has a special name. We're going to multiply by the conjugate. Have you heard that phrase before? It's also used with eyes sometimes. Conjugate is also used with eyes. And the conjugate just means that you are going to take whatever your binomial is and you change this sign in the middle. Just that sign. So, whenever you do that, you'll have 7 minus the square root of 14. And if you multiply by that in the denominator, you also have to multiply by that in the numerator. Okay, and this is why we multiply by the conjugate. So, in the numerator, let me think. I guess I'll go ahead and distribute. I'm going to distribute here, and I will get 28 minus 4 times the square root of 14. Okay. In the denominator, I've got to distribute like so. 7 times 7 is 49. 7 times square root of 14 is going to be minus 7 square root of 14. But right here in the middle, I'm going to get plus 7 square root of 14. And then I've got to multiply square root of 14 times negative square root of 14. That'll give me minus 14. Now, the reason we multiply by the conjugate is because if we have a plus sign here and a minus sign here, it makes it a difference of squares. It makes it where these middle two terms are going to cancel out every time. And if those middle two terms cancel out, you don't have any square roots left. So this would be 28 minus 4 square root of 14 over, let's see, we got to do 49 minus 14 is 35. It will not be. Okay, so I'm going to write down what Caleb just said. He said 4 minus 4 root 14 over 5. That's what you said, right? Don't write this down, but this is what Caleb said. We cannot do what Caleb just said because this 35 right here, it divides both of those terms in the top. So to divide, we would have to be able to divide both of them by 35. And that 4 right there will not reduce with the 45. So you have to be able to reduce both numbers there. And 35 does reduce with the 14, but the 14 is inside the square root. So since it's inside the square root, we can't reduce it with 35, which is not. So you cannot do this right here. You would just have to leave it like it is in this case. So our answer for that one would just be 28 minus 4 root 14 over 35. If we get one where we can divide both of those terms, or we can reduce both of those terms, then we would want to do that. But for this one, you cannot. However, I'm very glad that you said that because most students try that. We okay here? Have you done that before? Thinking maybe no. Caleb thinks maybe yes. It's a little fuzzy if we have done it before. Yeah. Okay. You may be like, when I went to AP Calculus training, about the third day we were doing slope fields, and I looked at that girl next to me and I said, I had never seen a slope field in my life. I didn't know what this teacher was talking about, slope fields. And she gave us a problem and we were working it out, and I was kind of figuring it out. But I was convinced I'd never seen it before in my whole life. And then she told us that that problem came from the 2004 released AP test. That is the year that I took the AP test. So I most certainly had seen it before, because I did well on that test. Like, I knew everything that was on it. I made a 5. I felt good about it. But I had no recollection of ever even doing any problems like that at all. So the further you get out when you haven't used something in a little while, sometimes it goes away quick. The good news is usually if you have seen it, it comes back a little faster than if you had never ever seen it before. But especially with math, it is easy for things to just disappear. This happens to names of students that I have had over the past 15 years. So if I see you in Walmart 10 years from now, and it seems I can't remember your name, just know it's my poor brain function that is the reason for that. I do feel like something's wrong with me sometimes, because I will see kids like I knew well. I remember the face, I might remember what class I had them in, and I cannot remember their names. Alright, so negative 9 minus square root of 14. We just changed the middle sign. Only the middle sign. So that 9 stays negative. We change this to a plus square root of 14. We need to multiply it on top and bottom, because, again, that's like just multiplying by 1, so it doesn't change the value. So if we distribute in the numerator, we will get positive 18 minus 2 square root of 14. In the denominator, we're going to do negative 9 times negative 9, which will give us positive 81. And if you have chosen your conjugate correctly, the outside terms, that negative 9 square root of 14, and the inside terms, which is going to be negative times negative, is going to give you a positive 9 square root of 14. They should cancel every time. I'm not going to write it down because I know they're going to cancel. And then I've got negative square root of 14 times positive square root of 14, which will give me negative 14. Yes, it should always be subtracting what's in the radical. The only exception to that would be is if that had like a 2 in front of it. Like if it was 2 root 14, then you would need to think about that a little harder. But if it's just a radical, then yes. So that's going to give us 18 minus 2 square root of 14 over, don't subtract those two. Part of me just then really wanted to do 18 minus 2 is 16. We cannot do that because that 2 is multiplied by the square root of 14, so they're not like terms. They're 81 minus 14, what's that give us? 67. And I've got 18, 2, and 67, these three numbers right here. Is there anything I could divide all three of those by? There's not. I know 67's odd. 2's the only thing you could divide 2 by. So this one will not reduce. You'll just leave it like it is. Okay, we got a couple more. This one's a little crazy because this one has all square roots. You still, it is the denominator that you want to rationalize. So you are multiplying by the square root of 10 minus the square root of 8. And notice that I am putting both the numerator and the denominator in parentheses because we are multiplying that whole numerator and the whole denominator by this square root of 10 minus square root of 8. So if we multiply the numerator square root of 2 times square root of 10 would be square root of 20. Square root of 2 times square root of 8 would be minus square root of 16, which is 4. If you wanted to go ahead and put that, you can. I'm going to wait till the next step. We got square root of 10 times square root of 10. That's square root of 100, or we could just go ahead and put 10 if we want. Yes. Because this is a positive right here and a positive right here that we're multiplying together. You only change the middle sign. Just the middle sign. For the conjugate, you only change the middle sign because you want it to be a difference of squares, so the middle terms will cancel out. So the way to do that is just change the middle sign. Yeah. And then for our last, we'll have minus the square root of 80. We're going to do some work on that top part this time. On the bottom, we're going to do square root of 10 times square root of 10, which will give us just 10. And then we'll get a minus square root of 80 plus square root of 80. Those two will cancel each other out. Right? That should always happen if you've chosen your conjugate correctly. And then square root of 8 times square root of 8, we get a minus 8 right there. Everybody okay here? All right, so then we need to simplify anything we can simplify. Square root of 20, will it break down? Yes. It could break down into 4 times 5, which is going to give us 2 root 5. Square root of 16 is just 4. And 80, we already did that one once, didn't we? It's 16 times 5, so it'll give us 4 root 5, and this will all be over 2. You can only combine things if they are like terms, so that means their square root parts has to be exactly the same. Thankfully, both of these are square roots of 5, so we can put those together, right? The negative 4 and the 10 is going to give me a 6. And then I've got 2 square root of 5, negative 4 square root of 5. Think of it like 2x minus 4x. It's going to give you negative 2 times the square root of 5 over 2. And we can simplify this because this time, if I'm looking at these numbers here, is there something I could divide them all by? 2. So if I divide all of those by 2 to reduce this, I would get 3 minus 1 square root of 5 over 1. I'm going overkill by writing those ones. This would just be 3 minus the square root of 5. Yes, you could. Okay, questions? All right, here's our last one. Our conjugate here would be 7 minus square root of 5. So for our numerator, 3 times 7 would give us 35. 5 times the square root of 5 is going to give me minus 5.
She said 3 times 7.
I did it right, though, right? 5 times 7 is 35. So we've got 5 times square root of 5 gives us a negative 5 square root of 5. Then we'll have to do the negative root 5 times 7, so it'll give us minus 7 root 5. And then we'll just get a plus 5 for that last term. Since that's negative times negative, we get a positive 5 there. we okay there? Numerator. In the denominator, 7 times 7 is 49. I know my outside terms and my inside terms will cancel, so I'm not going to put them down. And then square root of 5 and square root of 5 will get minus 5 here. So we will get 40 minus 12 root 5 over 44. I could divide all three of these numbers right here by 4. So you can only do it if you can divide all three of those numbers there. So that is going to give you 10 minus 3 root 5 over 11. And it won't reduce any further, so you leave it right there.